this area under the graph here, and in between here, we'll start here, in between, there's around, what's that, 5 kilos of force in between here, so which is what's holding the joint together the whole way through, right, through your whole range of motion. So that's what stops the pain of an acute sprain. But the total area under this graph, if you could continue it on over time, if you did it over time rather than range of motion, should be an amount of energy. And if you can equate that amount of energy that these braces can store up is greater than the amount of energy it takes to sprain a ligament, then it should be safe. Right? If the amount of energy it takes to, I'll come back off that. Where are we? Stop sharing. So essentially, if I can store up more energy as that rolls out and gets to that point, and there's, look, when you get to there, that's 15 kilos that you're not even feeling. Right? And that's what I found quite remarkable, is the amount of force they store up that you can't feel because it's anchoring onto the skin, not onto the bone. Whereas if this was anchoring onto your bones, you'd be feeling it. Well, probably more, but even though, because it's not a rigid strap, and that's where a lot of the braces go wrong, you know, and also the straps that come around and go across to the inside of the brace, they come across here and come across to the inside. The distance between here, where are we? Here on the outside and the inside of the brace over here doesn't change as the foot rolls around. Those braces, any brace that has a strap that comes across the foot is kind of unnecessary and it just adds bulk. So that's where essentially what I'm doing is providing a system that can store up more energy than it takes to sprain the ligament. And now the breaking strain I've seen is about 420 newton meters. And the other thing I'm doing is also using levers. I'm using the distance here. All right. I've now got a longer lever because I'm starting down here, whereas the actual ligaments are right up here, close to the joint. Right. Yeah. Right? So I've got a bit more of a lever arm, right? So I don't need the same amount of force out here. I've got probably half the force needed to rupture a ligament. But there's all these little unknowns. How much does it take? And the other thing is nobody seems to even consider the hydrostatic forces of that exist in an intact ankle. Right? They talk about the breaking strain of the, how much force it takes to rupture your ligaments. But if you've got an intact capsule, I've just done it with one of those big syringes. I don't have one with me, but a big syringe, if you cap the end of it, right, you can hang the bowling ball off it, right, just with the same size as, that round. Yeah, yeah. It creates the stability, but that's not even considered in the force that it takes to sprain your ankle. So there's a lot missing, and it's a pretty dumbed down industry, really, the ankle bracing industry. And I think that's partly by design. And
well, it's complicated. The ankle joint's very complicated, without question. So the foot and ankle in general, I mean, there's a lot of moving parts there. Yeah. So,
but there are moving parts, but there's the ankle joint. The primary ankle joint itself is just a subtalar joint and the tibiotalar joint. Right, that's what connects the foot and ankle together. Sure. And it's responsible for all that thing. So this system, whilst ankle surgeons use it for other things, is just for the most common injury, the lateral ankle sprain. Okay. It's not for other things. It's holding the joint together. And like for your condition, you might need some mechanical stability of the calcaneus. I'm not sure what it is that yours actually is, but this is just aimed at those 85% of ankle injuries, which are the most common injury of all. And that's why, it's not, well, I don't consider it rocket surgery. You know, I think it's simply, you roll your ankle. If you can store up during that roll more energy than it takes to sprain your ligaments, then it's safe. It's that simple, right? Because it rotates. Most injuries occur from that rotation. Treading on somebody's foot in a high, rapid force.
Yeah.
Right? And that's the thing that nothing at the moment, that severe injury, nobody yet can prevent the severe injury. And that's partly because they're not anchoring to something that's going to stay there. They're not using impulse suppression. They're not using that concept of spreading the force over time. They've just got a rigid strap. So when it comes in, even the one that recently the Germans have convinced their government to back them to do a thing called a better guard, and they got the NBA interested in as well. But it locks. I patented the same thing. I don't know how they got away with their patents when I first patented this, because I thought, well, if you have a material that the faster you load it, it then becomes rigid, right? So they have a thing with a dilettante, like a piston with a dilettante fluid in it. So when they load it fast, it then locks up. But when they anchor it over the sock, so even when it does load and lock up, it's locking up at an arbitrary range of motion. It's not allowing you to have your full range of motion, or it might. But then when it does, it's imparting a shock force to the bone or whatever. It's so to me, I abandoned it because, one, it wasn't going to increase the time of loading. You still had a imparting thing, and their results show that it's just as effective when it does lock up as a lace-up brace. Okay, so and that's the challenge for me, is that, and particularly with taping in the professional sports locker rooms, you know,
taping loosens up pretty easily, pretty fast, anyways.
But they're using it as PPE in a professional workplace.
Sure. Yep.
And that's where I've been advocating and making a bit of a stir on LinkedIn and other media, challenging the NOC SAE and to test ankle braces and tape. But their director is an athletic trainer, and their National Athletic Trainers Association has a foundation sponsor, Kramer. Right, so they're invested in taping. So taking a step back, what started me to think, so I've been able to do this for quite some time, I contacted when the NFL got sued for concussion. Right, that was a moment for me. I thought, oh, okay, now they're treating this stuff as workplace PPE. Okay, and the reason I tracked down the attorney that sued them, one of them, a guy in Atlanta, Jim Voiles. He's running another set of class actions at the moment for concussion as well, and said to him, well, what's the difference between selling the rights for ankle taping to a sponsor and not caring whether it's safe or not? What's the difference between what they did with helmets, where they just sold the rights to a helmet company and there was no matter of whether it was safe or not, and people got injured? He said, well, there's no difference. So they're looking at whether they can run a class action for preventable ankle harm. And as I pointed out, this is so much more prevalent and more costly than that helmet and head injuries is. You know, the concussion rate compared to the amount of ankle sprains and long-term trauma, because they're not repairing ankle sprains either. There's no evidence that any method of physiotherapy has ever repaired an ankle ligament. Okay, and there's studies recently by the Athletic Trainers Association, Osteoarthritis Alliance, to say that the ankle one or repeated sprains in the NFL increases your chance and likelihood of post-traumatic ankle osteoarthritis. So the evidence is already there that the harm's happening. That's what I've been saying to them. You've got to develop some sort of a test, because you can't just sell people's rights to a safe workplace to a tape company. But